Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations who are working on the summative. It is question number 7. A regular pentagon has a perimeter of 35 centimeters. What is the distance from the center of the pentagon to each vertex to the nearest centimeter? So, a regular pentagon, what is it? Well, a pentagon is just a five-sided polygon. So any polygon I draw that has 5 sides is a pentagon. Um, but a regular pentagon, just like any regular polygon, has a particular feature, which is that all the sides and therefore all the angles are the same. So I'm going to use my technology to draw, ooh, a perfect regular polygon. Isn't that lovely? So that's, a regular pentagon. That's a regular pentagon, right? 5 sides. And because I know it's regular, I know that each side is the same length. Boom, bitty boom, boom, boom. So what do I know? I know that it has a perimeter of 35. So if I call each side x, because they're all the same, so use only one variable, then I can easily solve for x because the perimeter would be x plus x plus x plus x plus x. I don't know how many x's I said, but there's 5 of them. So 35 equals 5x. So now I know that each side is 7 centimeters in length. So each side of this pentagon is 7 centimeters in length. So let's clean up this pentagon a little bit and look at the rest of the question. What is the distance from the center of the pentagon? So we'll put a dot here, right about there to represent the center. What is the distance from the center to each vertex to the nearest centimeter? So this is what I want to know. Let's call this D because it's a distance and that's what I want to know. And it doesn't matter where I draw that D from the center to any vertex, it would be the same because it's a regular pentagon. So I need to find D. So how am I going to do that? Well, if I draw another D over here, I can see that I've created a lovely triangle. And this triangle, I know that this is 7. So right now, I'm going to redraw just that special triangle that I'm looking at, where this is D, and this is D, and this is 7. So that's kind of nice. So because it's an isosceles triangle, meaning because these two sides are the same length, I know that this angle would be the same as this angle. So I don't know this angle, though. It would be great if I did. So let's again go back to a clean, nice pentagon and see what else we can discover. So I'm going to put that dot back in the middle because the angle that I'm looking for right now is this one. And dot, 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 just sort of give a hint. Oh, I'm making it messy. I'm looking for this angle here, right? So let's do this. So what do I know about that angle? Well, I know that that angle is one of 5 angles in the center of the pentagon. So here's the center of the pentagon, which I'm circling. But remember, as I'm circling, my pen is going through 360 degrees. So the sum of all of these angles, here, 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 is 360. And because it's a regular pentagon, each of those angles is identical. So I'm going to call that angle y, and of course, each of these is therefore angle y. And so I know that if I have 5 of those y's, I formed a full circle. And a full circle has 360 degrees. So this means that I know that each y is, calculator, I know that each of those is 72 degrees. So if I look back at my simple triangle, again, and that's this one that I stole, I know now that this angle is 72 degrees. And that's helpful to me because I can now tell you all of the angles in this triangle because this angle here is the same as this angle here. So I'm going to call this angle Z, and therefore this angle Z, and calculate what angle Z is. So in a triangle, the sum of the angles is 180. So in this triangle, I have 72 plus 2 Z's. So solving for Z, 180 minus 72 is 108. And then divide that by 2, and I get 54. So each of these angles here is 54 degrees. So let me just draw with all the details I have, and I'll use my fun technology here. Hey, look how beautiful. Yes, I'm very talented. Okay, so we know that this angle is 54. We know that this angle is also 54. We know that this angle was 72. This was 7 centimeters, and this distance, called D, is the one that I'm trying to figure out. So how can I find D? Well, this is a triangle where I know all of the angles and one of the sides, so we can just use the sine law. Now, I haven't given any labels to this triangle, so I'm just going to go ahead and say ABC, just so that I can set up a sine law with some reference points. So I'm going to say that sine A over side A is sine B over side B, which is the distance. And now I just have to solve for D, and I'm done. So cross multiplying, this is D times sine 72. And cross multiplying the other ones, I got 7 times sine 54. So I need to divide both sides by sine 72, divided by sine 72. So I get D is equal to this calculation, 7 times sine 54 divided by sine 72. And now I can just use my calculator and calculate what that distance is. So sine 54 times 7 divided by sine 72, I get 5.95, and it says to round to the nearest centimeter, so the distance is 6 centimeters. So in this pentagon, the distance from each vertex to the center is 6 centimeters. Okay, I hope that was helpful. A nice short video. See you soon.